Hello. A very good evening, everybody. Welcome to our webinar series, which is Wednesday webinar series. I welcome you all for the structural engineering webinar. Now, today, we are going to see some of the exciting topic and the people who really want to become the structural design engineer. Today, there is a session which is going to be a really exciting session for each one. Right? It's eye-opening sessions for some of you. That what kind of things that as a structural design engineer you require to have, how to proceed ahead. If you are already the design engineer, then how to go to the higher levels of roles and responsibilities. So all these things, let's further dive into the day's subjects. Let's get started. All right, so mastering a series of structural design engineering. Actually, you require this is basically a comprehensive guide for that actually. So ETABS is the software that we are going to go ahead. Yes, there is a series of software. It's not one software, right? So what are the series are there? How basically we are going to deal with this? What are the different types of projects are there? All these things actually will look into the why particularly we are going to discuss only thing about the ETABS, and then how we can go ahead into the deep dive inside the structural design engineering topic, right? So the next slide is basically, this very important slide. You can take the picture or the photograph of this so that you will understand this. This is there on our website also, e-construct.in. That is the website name. All right. So I'll just explain you this a little bit further. First of all, to master the structural engineering, this is a curriculum also that we are basically taking the master study course in our company. In that, you really require to learn the structural engineering fundamentals. What are the fundamentals are there? One is finite element based, performance based analysis, different types of analysis like linear, non-linear, static analysis, dynamic analysis. Then structural engineering judgment is one type of things actually. Then you will see the engineering, value engineering. Then structural detailing, how that's not a StatPro model or ETABS model, a SAP model goes to the site, which is basically the detailing, means the drawing that goes to the site. Then site requirement and certain thumb rules also you require. So this is known as the judgment. All right, what is judgment actually? If you ask me, the structural engineering is basically, this particular thing is a judgmental science. If you see the geotechnical engineering, this is hypothetical science. Hypothetical. Do you remember in the college days we have seen that certain curve, sine curve, cosine curve and all actually. It begins with certain type of theta, angle theta, graph and all actually. So let's say sine theta. Sine theta. So theta represents what is the angle. So based on that actually the curve starts. Alright. So what happens is, so this is the nature actually how the curve begins, how it goes. So similarly, if you really want to become the structural design engineer, you should know the curve, you should know the angle, how does it goes, how does this has to perform. Okay, so many people actually who wanted to become structural design engineer, they follow the graph of computer science engineering. So isko itna salary mila. This guy has got this much salary package. He got this much. He got that much. He got this thing. He got that thing. It doesn't work out that way. Structural engineering is very robust actually science. It's fundamental science and it's related to the each and every branch of the structural engineering. If war happens actually, structural engineering would be extremely high in demand because a lot of buildings got collapsed just after the war. So obviously that will happen, but computer science will be nowhere because the servers are got collapsed. Right, so different line is there. What I'm saying is actually it's a different line. So you need to deal with that line. Right? So what are the things are there actually? One is actually different types of fundamental, it is basically the engineering based, fundamental based knowledge that you require to have. And these are some of them. These are not all of them. These are some of them, right? Another thing is the code based knowledge. What are the code? One is Indian code. Indian code means what are the codes? Are the IS456, IS800, IS875, Part 1, Part 2, Part 3, IS1893, IS16700, IS13920. These are some of the codes. There are more than 300 to 400 types, 300 to 400 different codes actually. As a structural engineer, as a civil engineer, you might require to consider. Let's say 3370 is the underground water tank related code. So these are some of the codes that you really require to understand, which is must actually you need to know. Along with that, certain international codes also, BS8110, ACI 318, CBFIB code, or UBC 97. These are some of the international codes. So what are the Indian codes are saying? What are the international codes are saying? So you'll get the broader perspective of the structural engineering science as a principle actually. Later on, you will see the software-based knowledge. So ETABS basics, ETABS advanced, SAFE, SAP 2000. SAFE is basically the foundation-based engineering. I'll give you the examples also later on. SAFE is what? It's a foundation-based. This is basically the infrastructure. So somebody will say, sir, there are so many softwares are there. Strand is there, Strap is there, then STAD Pro, then you are having Procon, you are having Robot, RAM concept, then so many different softwares are you are having. So any particular person would get confused that which one you need to deal with it. So these are basically the in-depth softwares that you would require. And then there are certain add-on softwares like CSI Bridge, RCDC, Procon, STAD Pro, CSI Detailer and all actually. Then this is basically, we call it as the software-based knowledge. So these three things are very, very important. And the fourth thing is the types of projects. What are the types of projects? I'll just hide it myself actually so that you can see me better. So you'll see that here, these are basically, RCC, steel, composite, pre-beep, which is pre-engineered structure, shuttering design, post-tension design, prefab structure. Many, many different types of structures also you would require to understand. How do you design? How do you analyze? How do you model it? How to get the output out? How many parameters that we need to give? What kind of parameters we need to give? Why it has to be given? How it has to be given? Once it is given, how to check it? All these things actually are required, right? All right. So are you getting, you can put that in the chat box if you are having certain problems or something, we'll definitely solve it. Later on, actually, you'll see that why we have taken the ETABS as a software over here. Because Burj Khalifa got designed into it, and so many other softwares also actually they have used it for designing this. You'll see that, you know, ETABS is basically developed by Computers and Structures, CSI, it's an American company. And they have been into this particular business of developing the structural engineering software since ages, actually, decades, basically almost for 20, 30 years they are into this business. And many, many projects has got developed, designed in here and got it constructed and all, 50, 70, 80 story building. Burj Khalifa is 156-story building that has got developed, designed into this. So, you can rely on this actually. See, as a career, you should be relying on something actually. That reliability is very important. So you can definitely rely on this. This is extremely fast into modeling, analysis, designing and all actually. I'll show you, I'll give you a small demo of this actually. Then it gives you modeling window, manipulations, data creation, many, many things are there. Different types of analysis it can do. Okay, static, dynamic, linear, non-linear, many, many different types of analysis it can do and all actually. This is also having a connection to the BIM softwares also, right? Now, coming to the next one, actually, you will see that steel structure, RC structure. As a structural engineer, you require definitely the concrete structures, which is RC structure. Then definitely, another one is the steel structure. Then the third one is actually, we call it as the composite structure. Then the last one actually over here, it is pre-engineered structures, right? So so many different types of structural configurations. It can, give you it can help you to model, analyze, and design and everything. Post processor is also extremely fast. Okay, so RCC is, cornerstone of the most of the projects. So it offers, more durability, especially in the foundations, columns, and slab and all. Actual steel structure, it is basically high-rise buildings, bridges, and many many other. It gives you when the tension is there, steel is one of the very important areas. Easy to erect, easy to construct, remodeling, changes are extremely easy in the steel structure. Composite structures actually, it is offering the enhanced performance in certain complex projects. Right? Pre-engineered structures is like, it is basically for the efficiency, speed in the construction. If you really want to have industrial, commercial buildings, pre-engineered is the structures actually, and ETABS gives the basically the help to all the this type of structural modeling, analysis, and design, detailing, and all. The next one is actually when it comes to the defining the contract, modeling the concrete elements, and assigning. Now, this is basically the concrete structure. Actually, if you ask me. So let's start doing that. Actually, if you, I'll just show you. Seeing is believing. So here is the 50-story building. Actually, yeah, I'll just show you. So from here, you can define what kind of build, sections that you required, the materials that are required, the slab sections that are required, and all actually. And here is the model, right? In the model, you will see that over here there is a shear wall, there is a slab here, there is a beam here, there is a column here. This is the global axis coordinate, which is, this is in X direction, this is in Y direction, and all actually. And if you want to do something, some changes and all, it's very easy. Let's say I wanted to change these two columns. I'll just, drag and drop this over here. I had to unlock this model actually. I'll just unlock it. And I'll just drag and drop this to here. We'll see that instead of a rectangular column, now it is a circular column. You have to just unlock the model. Actually. Now then you give the different types of loading conditions and all actually. From here you will see that, how the dead loads are there. These are the dead loads, how the live loads are there. Right? Then if you are adding certain point loads and all, also you can add it from here. You can check it from here. So let's say this is the loading for the wind load conditions. You can go here and check what are the wind load parameters and all actually. So these are the parameters of the wind load and all. What are the earthquake load parameters? You define the parameters, add it, analyze it, model it, analyze it, and then design it. It's very simple. I'll just analyze this now. So this is a 50-story building. Now I started just the analysis. It takes hardly a few minutes, less than 2 minutes to just analyze it and show you the results. Right? So it is that intuitively fast. Actually. So the moment if you analyze it, you will unlock it, you will see that the analysis results will go away from here. The moment you analyze it, again the analysis results will be there here. Now it is doing the modal analysis and other things. So these are the different modes. This is the current, what is the time, what type of analysis it is doing, and all actually. So within just hardly less than 2 or 3 minutes, you would see that a 50-story building analysis would be, over, and just you will at any moment of time you'll see the results are there. So here these are the details and all. You'll see the analysis is complete, and boom, these are the results with the, if there are certain warnings and all, you'll see it here. So if you go to the 3D, you will see that the 3D deflection, the first thing that the software shows you is the dead load deflection is in mm. And just hover the mouse, you will see that, you will see the results here. Yes. Right. So this is how it is so strong actually. Now this is the deflection shape. So post processor is also extremely strong. Now I wanted to see, for example, the bending moment diagram. Just go here. This is the bending moment diagram. No, I wanted to see the bending moment diagram of individual beam and all actually. So no problem. You go to this one particular floor and this is the bending moment diagram. I wanted to see the bending moment diagram or the shear force diagram. I want to see shear force. This is shear force diagram. I wanted to see the bending moment of a slab. This is the beam actually. I wanted to see for the slab. So let's say you go to this place, then you go to dead load and go to the bending moment in one direction, the bending moment of the slab. I want to see the deflection of a particular beam or a grid or something like that. So this is the deflection shape. Now I wanted to see the deflection of this particular grid. No problem. You go to the draw developed elevation. Just say developed elevation of let's say from here to here. Right click it. You will see this here, and this is the shear force diagram. This is the bending moment diagram of that particular grid. You want to see the deflection diagram of this. You'll see the deflection diagram of this. This is how the deflection is there. So this is the entire building and the individual grid also. Now, apart from that, there are so many different functions are there over here. So let's say, for example, I want to see the virtual work versus energy diagrams. So this is the force versus the deflection. Means which particular mode is governing the maximum and which columns are really binding for that actually. That is this is the graph for that. So let's say I wanted to hide the certain beams and slabs and all actually. So these columns and shear walls are governing more for the first mode. First mode, which is the force, and the first mode that is displacement, is these are the shear walls which are governing the max in the first mode itself. Right. So this is what the diagram is all about, and I would like to showcase the entire thing now. Apart from this, there are many other functions are there in the analysis itself actually. So what are the functions? So let's get dive into the subject. Like here, if you go here, you will see that there is a maximum deflection, the modal deflections, how much it is. You will see the how much is the force acting on this. So on the 58th story building, actually, this is the total number of force which is over here. See here, the graph. So how much is the force acting on the story number 30, story number 40, story number 45, lateral loads. You know that there is a formulation actually. So WIHI square divided by summation of WIHI square. So based on that, actually, you will see the automatically the figures are there. So at this particular floor, how much is the value? How this particular floor, how much is the value? You can see that here. Now somebody will say that it is there in the graphical format. I want it to be there in the report format. So from here you will get the summary report. Also show the table. Let's say show formatted table. You will get the table itself. You wanted to export this in Excel. Just export it in Excel. Here there is Excel file. Automatically it will be exported to the Excel. So these are the elevations and these are the forces, the X direction from zero base to the top floor. How much is the force coming in the X direction? Now somebody will say, sir, what about Y direction? You go here in the Y direction. Same thing, you press this button, put this formatted here, put that in Excel, it will go to the Excel. Very intuitive, guys. Very beautiful software. Trust me. You can save the report. You can have any different. Now, this is basically the plots. Like that, there is a story stiffness plots actually. So there is a story stiffness. individual. So soft story and all actually you can find out from here. There is diaphragm drift actually. The individual floor, how it is getting deflected against the spec X condition. Like that. So many different permutations and combinations are there here. A lot of, now you have seen this. Along with that, you want to see the tables. So from here, you will see the different tables. For example, here you want to see the modal mass participation. You want to see the reactions. Just say, okay. All the tables are there. And every table, actually, you can export this table to Excel. So this is the table. Event reaction. Modal mass participation. This is the modal mass participation. Now let's go to the top floor actually over here, maybe this. And let's see the first mode. To the mode number 1. Apply this. The mode 1 is it is the torsion. It's a torsion actually. So why it is the torsion? How it can be reduced? What kind of can be done to have the translation mode? All these things actually will be there in the modal mass participation ratio, which is this particular table. This table, which is modal mass participating. So first mode is under rotation, which is 42%. Second mode, it is under translation, which is UY, right? Let's say I'll go to the mode number 2, second mode, just apply animate. Yes. So this is the Y direction. That actually you can see that from the report only. From here only. See here. This is mode number 2. What is the time period? 8 point something. So here also it is 8 point something. This is the same time period. So based on that, actually, we'll start working on this. So this the time period is perfect, or it has to be less. So 50-story building generally 5 to 6 seconds is okay. The 8 second is slightly higher. Since the building is slender, the aspect ratio is quite high actually, like this, and to this ratio is quite high. That's why the time period is quite more. The building is more flexible actually. Related to the foundations, these are the foundations. I mean, these are the forces coming into the ground. Now, how I look into it, I can't say anything. You go to the base, still I can't say anything. No problem. Go to the tabulated, right? So FX, FY, these are the forces. Now, still I'm not able to do anything. I can't see this properly. No problem. You go to the base, and instead of 4 decimals, you give 0 decimals. You can see that, and same thing you can give it in for the moments. Moments also. Instead of this, I'll go 0. Alright. So this is how it is. Easily you can take the printout of this and start working. Right. So it is very intuitive software, extremely fast. Deflection shape, all the dimensions would be there and all actually. Stresses, calculations, any moments, many things are very easy. Right. So that's why this is more intuitive. For designing also, it's very simple actually. From here, you can just go to the concrete design, just select the kind of combinations that you require, and from here, just go to the design part. It's very lightning fast actually, the designing is also. So such kind of facilities are existing in this particular software called ETABS. This is extremely good for the superstructure, high-rise buildings and all. It is extremely for steel structures. I would prefer that this is also you can use it. SAP 2000 is also one of my favorite software, and StatPro also people are using majorly for the steel structure. For RC structure, people are not using StatPro. I repeat, for RC structure, people are not using StatPro. Right? For steel structure, steel people are using it, but with certain limitations. Right? So this is the designing is of the entire building is over. Not one floor actually, entire building is over. So from here you will see that what is the reinforcement diagram and all actually. You will see that what are the diagrams and all actually. From here you will get the details. Many details would be there. Here. Right? So designing of the frame elements can be done. Concrete frame elements, composite elements, composite columns, joist, shear wall, slab design, many other detailing is also there here actually. You can do certain detailing aspects also. Right. I'd like to give the, let's say for example, lock this or select preferences. I'll just make sure that the designing will take the combination which is dead load, load. I'll remove this for the just for the sake of detailing purpose. So I'm again redesigning this with the dead load, load. I'm removing the earthquake load and all actually just for you to check the design aspect, the detailing aspect of this. You can also do the detailing of this, but certain areas you will see the overstressed, means the beams and all are failing. You can also go to the shear wall designing also. Let's say I'll go to the shear wall designing. Shear wall designing you will be there. Like that, it is 50-story building. It's not like 5 to 10-story building or something like that. For 50-story building also, you will see that the designing will be comparatively quite faster. Right. So it will take, I think, couple of minutes because the shear wall takes a little longer time. So I'd like to go with the modeling process, designing process, structural steel, and performing the structural analysis also. What are the different types of analysis are there? Let's say, for example, varied variety of different types of analysis are there. Linear static, linear dynamic, non-linear dynamic, many different types are there. Let's say here, if you go, you'll see that linear static, non-linear staged construction, modal analysis. In the modal also you'll have the eigenvectors and ridged vectors, eigen and ridged vectors. Then response spectrum analysis and time history analysis. Time history analysis also you'll have the linear time history, FNA, linear direct integration, non-linear direct integration. Then you'll have a buckling analysis, which is dynamic analysis, and also hyperstatic analysis, which is generally for the PT post tensions and all actually. So these are the types of analysis that ETABS is having. Along with that, you will be having the creep analysis also. How to do that? We'll see that over here. You go to this particular place and you will see the creep related parameters. Generally for that we check the CBFIP code. CBFIP 10 in 2010 is also very good. You can see the New Zealand code also, or maybe the Euro code, or maybe ACI code. If you do not believe on any of these codes, you can go to the user defined. You can define, your own values here actually related to curvilinear data. So these are basically the time dependent parameters that you can have over here. So let's say TBFIB code and what kind of graphs are there. So based on that, the creep analysis, shrinkage analysis, or compressive strength analysis can happen. All right. So this is related to the non-linear types. P delta analysis is there, which is the you know based on the iterative, based on the mass basis and all actually. So many different types of analysis are available here. That's the reason this particular software becomes very intuitive. Let's say I'll analyze this model. Then I'll do the designing of this and designing of the shear walls also. So this is the shear wall. I'll do the designing of the slab also. The designing of the slab also got over. This is the designing of the slab. This is the designing of the beams, how the top reinforcement, bottom reinforcement, AST, everything you will be getting. Along with that, actually, you will be seeing the detailing portion also. I'll show the detailing portion a little while, but let's say display design info of longitudinal steel. Yes. So this is the top reinforcement. This is the bottom reinforcement. Top reinforcement, bottom reinforcement, top reinforcement. Like that, you will see here. All right. So this is the beam design. You will also see the column design. The column design. Now I can't see the column. No problem. I'll just remove all the other things and show you the columns and the shear walls. Still, I can't find out anything properly. So I'll just show you the display design info of the rebar percentages. And if you want to showcase them only for certain floor limits, you can also see them. There are only 3 floors and all actually. Then you can easily see what's happening here. All right, so these are certain functionalities. It's very intuitive, fast, very much, reliable. Results are very much reliable. Right, so I'll just add all the things. And now this is the deflection shape of this building, the bending moment diagram and all actually. So many things are there. Now since the designing is done, actually we can go for the detailing. Right, so what are the rules are there? You will see these are the rules. For example, calculate the rebars. So like that actually, then it can go to the rebar detailing also. Okay, so rebar detailing means it will go to the CSI detailer for the detailing of this kind of things. If I want to see the flexural reinforcement of a particular slab, the top rebar, I can go here and check. I want to see the bottom rebar. Or look at this. This is AST upon SV. Square steel per meter is what it will show you. So like that, many functionalities are existing here. It's very intuitive software and all actually. At every moment you will see the help. The documentation also it is there. I want to see the documentation of this. For example, I'll just save this. I'll go here and I can watch the video. Oh, sorry, the report. So this is the report. You can just press W here. It will show in the Word file. From here, you will go to the Word document. It will open it in the Word document. Entire project report is ready. It is very fast, extremely fast. When I'm saying you please rely, just rely. Don't see around. Right? So this is how it is. Okay, so these are the details. You can see the modeling of the steel members, connections, and all actual. So let's say I'll show you the other aspects of this. So you want to go here and see what kind of sections that you require. Now, yes, this is the building which I've shown you. This is the entire building. Designing and all will be done. Just unlock this now. Now from here, if you want to see that, you want to add the concrete sections, you can add it. You want to add the tubular sections, you can add it. You can add a steel I sections. You can add the I sections. You can also import the I sections like this. You can import. This is ISSC. You can go to the Indian. So ISHB, ISLB, ISMB, all the sections are there. Whereas if you want to create, your own sections, non-prismatic sections, or maybe section designers. Let's say I want to say, deal with the concrete. Let's say this is the circular column to give the I sections, the I section. And let's say this particular column I wanted to give as, let's say 900. This is the reinforced concrete. So this is how it is, so nice, and based on that the properties would be there. Based on that the curvature and all will be there. Now this particular section I want to use it. So let's say F6 section 1. I'll just go to the all floors here and I'll select this column. I'll select this column and this column as F section 1. So I hope you can see that, the section which I have defined recently just here. Yes, so it is over here. And you can again analyze it and start modeling, designing, checking and all. All these functionalities are there, along with that the reporting and all. So this particular software is extremely important, and for you to master and all, connection and many other things are there actually over here. Analysis, composite also it can do. Composite is, there are 3 types of composite systems are there. The one which composite which I shown you inside the RCC column, you will have the I section. So this is one type of composite. So there are 3 to 4 different types of compositions are there that you can develop, like this also. Combined material, modeling types, analysis types, ductile detailing, many other types of designing and detailing options are possible. Pre-engineered structures also you can do. Okay, so you can define the material which is the pre-engineered shape actually, how based on the bending moment, like this it is changing. So such kind of structure also you can deal with this. Analysis, design, optimization and all. Load combinations, so dead load, live load, wind load, earthquake load, snow load, many different types of categories of the load. So let's say over here you go to the define, and what are the categories of the loads. You can see that dead load, live load, superimposed roof live load, reducible live load, notional load, which is there in the NBCC code, which is Canadian code. Earthquake load, snow load, wind load, construction, distressed, and if something is not listed here, there is other load also you can define. So like that, my friends, I would like to tell you, this is very deep rooted and simplified software. Okay, it's very deep, very deep. Okay, nobody can claim, including myself, that 101% I know every damn thing. It's so deep, right? So like that, there are so many different functionalities are there, designing functionalities, detailing functionality, graphical functionalities for the, checking and reviewing. All right. So like that, the load patterns you can define. You can have the static, dynamic, and the scale factor also. Different types of scaling and all also will be there. Right. OBS problem. So different types of static analysis, dynamic analysis, modal analysis, time history analysis. I have shown you that variety of different types of analysis would be there here. Designing and detailing of the certain things would be there. So different shapes of columns also you can have. Now this is just one of the image. This is decoration basically, but the designing composite kind of things also you can have it here. Right, so material optimization, cost optimization, weight optimization, and efficiency can be easily achieved through this. All right. So basically, if you ask me, if you really want to, become the structural engineer, CSI is one particular platform that you should rely, and there are softwares like ETABS, which is just now I shown you. Then SAP 2000 is another software. This is for buildings. This is for infrastructure. Infrastructure means underground tank, road, water tanks, and all actually. Then you will see the SAFE. SAFE is basically the foundation related software. SAFE. Then another thing is actually you will have the CSI call, CSI detailer, CSI bridge. Those are bridge designing and other software. So like that, Perform 3D is also there. So many variety of different softwares are there that you can learn. So whenever you're dealing with CSI, you deal with CSI only. Don't deal with the Bentley. Okay, Bentley is another company. Bentley means STAD Pro, STAD Pro, and STAD Foundation. So these are the softwares which are related to the Bentley. Then there is another company which we call it as the this Midas. In the Midas also varied variety of different softwares are there. So start, thinking only in one area. Let's say CSI means only learn the CSI related programs. That would be really helpful for you. If you learn ETABS, if you learn Midas, if you learn STAT foundations, no use, right? So like that, in a sequential basis, you need to start learning. All right, guys. So if you are having any kind of doubts or something, please put that in the chat box. We'll definitely go through it. Please put the, your reviews or your attendance or something actually in the form that is given to you. All right. And if you are having any kind of doubts or anything, please let me know. All right. So we'll definitely come back to you and we'll definitely resolve the problems that you might be having. All right. So thank you so much for attending this webinar, and I'm sure that this particular webinar will take it to you completely different level. There are so many other things which I wanted to show you. This is related to the foundation. Foundation means what kind of foundations are there, what kind of loadings are there. Many things are there over here. Yeah, so this is the foundation. This is the safe software, guys. Safe software. Without safe, the foundation cannot be safe. So how you will see that, see over here, there is a point spring constant, there is a point load, there is this particular thing is the drop panel, this is the raft, this is the portion where the central core is resting on it. So like that, many varied variety of things are happening here actually, and you really need to know many things to go ahead. Let's say I'll show you the extrusion view of this. So these are the shear walls and all are resting on it. So try to learn this kind of try to learn this kind of tools so that you will get to know many things and I'm sure that, um, uh, you can be a very good designer. I'm a structural engineer by profession, and I'm really compassionate towards the structural line, right? If you really want to learn, try to master into the software code and principles, structural engineering principles. These three things. If you learn only one, so this is one route: software. Second one is code. Third one is site related parameters and the project related things. These four are the pillars actually of your structural engineering career, right? If you really want to learn more, actually you can go to our website. So this is the website, e-construct.in is the name of the website, e-construct.in. I'll put that in the chat box. Please go through it. We are doing also courses. There are so many people are getting the benefit out of this. You can go through that. We teach all of these things also. We train you guys. People are getting 100% placement. The people who are taking this course, 100%. You go to NIT, IIT also, they are not getting the placements. From us, we are getting the placement. If you do not do the course, also it is fine. You learn the software, which is ETABS software, safe software, CSI Bridge, CSI Color, all the software. It takes, perseverance. So slowly, steadily, you need to learn this further more. Okay, and through that also you can opt for the good jobs. Okay, minimum 50,000 salary within a period of one couple of years time you can easily earn per month. All right, and the salary package goes as high as like around 15 to 20 lakhs also. Okay, so it depends upon how you are achieving. We have already given the webinars and all in that particular area. Please go through that. Right, so stay tuned with us. I will see you in the next webinar, which is going to come in the next Wednesday, same time, same place. Thank you so much. Bye bye.